What's the purpose of packing? Simply to minimize leakage along the pump shaft. It does that by sealing the clearance space between the shaft and the casing. A throat bushing keeps the gland follower from forcing the packing into the eye of the impeller. Packing is soft and pliable, usually made of cotton, asbestos, or flax. It's woven or braided into a continuous square-shaped strand. Generally, it's coated with graphite or Teflon for lubrication, and since it's softer than the shaft, there's no damage to the shaft when it rubs against the packing. Still, additional lubrication is needed to cut friction to a minimum. Some fluid leaks out of the stuffing box. That's normal, and even good, because it provides more lubrication between the shaft and packing. Lantern rings are sometimes used to pressure lubricate the packing. These perforated metal rings are located between layers of packing in the stuffing box. They allow additional fluid from the gland sealing line to be injected into the stuffing box. That helps lubricate the packing. Look closely and you'll see that this piece called a gland follower fits into the open end of the stuffing box. It holds the packing and lantern ring in place against the throat bushing. If you adjust the gland follower's pressure against the other parts of the packing gland, you can regulate the flow and leakage rate of the fluid lubricant. Although many centrifugal pumps use braided packing in stuffing boxes, in the petroleum industry, mechanical seals are more and more the norm for three key reasons. They don't require leakage, which means greater safety when pumping hydrocarbons. They last far longer than packing, and they need less maintenance. Those points are especially important if the pump's in a hard-to-reach or inaccessible location. There's a wide range of mechanical seals available today, but they all have similar methods of operation and similar components. Rotating parts are attached to the shaft. Stationary parts are secured to the seal plate. The seal plate is bolted directly to the casing. The highly polished sealing faces of the rotating and stationary parts are held in contact by one or more springs. In this manner, a seal is made to prevent leakage. That's the typical structure for all mechanical seals. Let's go on to bearings. Bearings basically support the shaft and reduce friction as it rotates in the casing. They also do two other things, as you'll recall from Section 1. They control the forward and backward movement or thrust of the shaft, and they control the side-to-side or radial movement of the shaft. Centrifugal pumps use two kinds of bearings, ball bearings and sleeve bearings. Inside this circular ring are smooth metal balls that are free to roll as the shaft rotates. These are ball bearings. They're usually lubricated with oil or grease. The sleeve type is stationary. It's made of smooth metal cylinders in which the shaft rotates. Sleeve bearings are lubricated and cooled by a thin film of oil between the bearing surface and the shaft. That oil is brought to the sleeve by a ring oiler or under pressure from a lube oil pump. The ring oiler transfers oil from an oil reservoir to the pump shaft and the sleeve bearings. It's critical to lubricate bearings properly. Without adequate lubrication, bearings will overheat, rust, or corrode, and sooner or later cause the shaft to seize or stop. Centrifugal pumps can get hot, especially large pumps or those moving high-temperature fluids. Excess heat is most damaging to bearings and packing glands. Sometimes this heat is carried away by the ambient air or by fluid being pumped. When it's not, Water jackets are frequently used to provide additional cooling. These jackets are channels located in the casing, near bearing housings and packing glands. Water or another coolant is pumped through the channels to absorb the heat. That water or coolant is then either pumped to a sewer or to a heat exchanger to be cooled before it's recycled back through the water jackets.